In this video, we are going to solve example 6.6 that is taken from chapter number 6, Bending, and book name is Mechanics of Materials by RC Hibbeler, 9th edition. So statement is draw the shear and moment diagram for the beam shown in figure 6-12A. So this is the figure. This is a simply supported beam having pin support at this end and a roller support at this end. The total length of the beam is 2L, and at the mid of beam there is a movement which is clockwise and is represented by m0. So you have to draw the shear force and bending moment diagram. Let's start with the solution. First step is that if you remove this pin support at this point, so you will be having a vertical reaction force which will be equal to R. And if I take it as 0.1, so it will be R1Y. And similarly, you will be having a horizontal reaction force which will be equal to R1X. And similarly, if you remove this roller support at other point and let me take this point 2, so this roller support only offer a vertical reaction force which is R2Y. Now we'll find this R1X, R1Y and R2Y by using equation of equilibrium. So first equation of equilibrium is that sum of all forces along x direction must be equal to 0 and force toward right is taken as positive. So from the diagram you can see only horizontal force is acting is R1X and there is no other force, so it means that R1X is equal to 0. Now we'll find this another force R1Y by using equation of equilibrium, that sum of all movement about point 2 is equal to 0 and taking the counterclockwise movement as positive. So about point 2, the first movement is this one which is external movement m0, that is clockwise, so it will be negative. So I can write minus m0. The second movement that is produced by this R1Y force into perpendicular distance is 2L and this is also clockwise, so it will be negative. So I can write is minus R1Y multiplied by 2L is equal to 0. So from here we will get this minus m0 will be equal to 2R1Y into L. And from here you will get R1Y will be equal to minus m0 over 2L. Now negative sign means, let me write it, negative sign means that your assumed direction which you have taken here upward is wrong and R1Y should be downward. So I can write it that R1Y is equal to m0 over 2L, and that is arrow sign shows that it should be downward. Now we'll find this R2Y by using third equation of equilibrium, that sum of all forces along y direction must be equal to 0 and upward force is taken as positive. So along y direction one force is R1Y and another one is R2Y, and we will not see over here that it is upward. R1Y is downward, so it will be minus m0 over 2L plus R2Y which is taken as upward is equal to 0. So from here R2Y will be equal to m0 over 2L. Since its value is positive, it means that your assumed direction of R2 which is upward is correct. The reason why I have taken R1Y upward in order to show you that you can take any direction and your answer will tell you about whether it is taken correct or wrong. Okay, now we have all these three values, so we will move toward drawing shear force and bending moment diagram. For that I have to draw the vertical line from the end of the beam and then a horizontal line to show the length x, where x can be any length. X start from 0 and less or equal to 2L, and on y-axis you will have to take shear force. Okay, let's we take one of this will be equal to m0 over 2L. The another one will be m0 over 4L and so on. Similarly, minus m0 over 2L. You can take any one, m naught minus m naught over 4L. Okay. Starting from the first point, you can see at this point you have R1Y which was downward, and that is m naught over 2L. So what we can say is that this is your first point. Okay, let me choose a blue color. Okay, this will be your first point. Okay, starting from this till end, there is no other vertical shear force, so it means that your shear force will be a horizontal line till end, and at the end you can see R2Y which is plus 2 m naught over 2L. It will bring it to the 0. So this will be your shear force diagram. Now we'll draw the bending moment diagram. For that I will draw a horizontal line to show the length x, where x is greater or equal to 0 and less or equal to 2L, and on y-axis you will take moment. Okay, now we will take, we will take here is m naught over 4, this will be m naught over 2, and similarly on in downward minus m naught over 4 and minus m naught over 2. Clear? Okay, starting from the first point, you can see at this point we do not have shear force because bending moment, because at x is equal to 0 bending moment is equal to 0. So your first point will be this one. Let me draw it by using pink colors. This will be your first bending moment. Now you can see at the mid of this beam there is a bending moment. There is a moment, external moment m naught. So what we are going to do is that we will find the area under the shear force diagram till the mid, and this area you can see is a rectangle, and its height is minus m naught over 2L and length is L. So it will give you minus area will be equal to minus m naught over 2L multiplied by L, and that will give you minus m naught over 2 at the mid. So m naught over 2 at the mid means that minus m naught over 2 will give you minus m naught over 2 at the mid will be this point. Let me write it minus m naught by 2. And you can see that shear force is a horizontal line with 0 degree, and this area is negative. So bending moment will be 1 degree higher, and it will be a straight line by joining these 2 points, not curve. It will be a straight line by joining 2 the points, and slope will be decreasing. And you can see at this point you have external moment m naught that is acting on it in clockwise. So while drawing the bending moment, the clockwise will cause the bending moment curve to go upward. So what will be the net? The net moment will be equal to minus m naught over 2 plus m naught, and that will give you plus m naught by 2. So bending moment will change from this to plus m naught over 2. Okay. Now the remaining area is this area, and you can see this area is again the same, which is height is minus m naught over 2L multiplied by the length is L, which will give you minus m naught over L. Okay. So plus m naught over 2L. Oh, sorry. Minus m naught, L will cancel this, so minus m naught over 2. So plus m naught over 2 minus m naught over 2 will give you 0 at this point. I will repeat it. You can see here the bending moment is m naught over 2L, and this remaining area will give you minus m naught over 2. Why? Because you can see the height is minus m naught over 2L and the length is L. So if you multiply, it will give you minus m naught over 2. So minus plus m naught over 2 minus m naught over 2 will give you 0 point at this. So your bending moment at the end will be this point. And you can see that shear force is a horizontal line with 0 degree, and this area is negative. So bending moment will be a straight line, and its slope will be decreasing. So this will be your bending moment diagram. Okay. And that was all about this example 6.6. I hope you have enjoyed this video and you have learned from it. Those who are new to my channel, then subscribe it and don't forget to press the bell icon so that you can get notification about my latest videos. If you have any question, you can ask me in comment section. Thank you for watching.